We turn unwanted waste into clean energy. Solid waste or any other carbonaceous material from landfill or municipality is processed in our altered waste-to-energy plant to produce ready-to-distribute electricity. The backbone of this joint venture is a novel process method utilizing steam reforming to process waste, carbonaceous material, into clean energy. Amalaterra holds the Certificate of Registration issued by the Canadian Intellectual Property Office of the Department of Innovation, Science and Economic Development. We are now ready to use the technology as originally intended to make the world a cleaner and better place to live. Steam reformation is a well-known novel process and has been used for many years in the chemical processing manufacturing industries. For example, production of hydrogen from methane, concrete industry, etc. The method of steam reformation is a historic process, and the way we use this process in reforming carbonaceous materials is both simple and ingenious. Any form of carbon-based material is reduced to the atomic level of the feedstock constituents and converted into syngas, which is made up of carbon monoxide, hydrogen, and low volumes of other gaseous material. Among the strengths and ingenuity of our method, we adopt a novel application of rotary kiln technology and steam reformation for the conversion of waste, and we do not require any exotic materials and catalysts in the reformation process. There are 4 simple pillars in the Amalaterra waste processing system, all designed to optimize the mass, energy, and water balances of the process. 1. Waste handling. 2. Reactor. 3. Gas cleanup. And 4. Power production. Waste is collected and delivered to the facility, where it undergoes sorting of non-reactive inert material in the waste. Preparation of the waste inputs for processing are minimal, requiring shredding and screening. For example, for bulk items, metal, concrete, and glass are removed. All MSW feedstock material is received and processed in an enclosed facility under a low vacuum to improve the aesthetics of the waste's handling and to prevent fugitive dust and odor emissions. Carbonaceous feedstock material may be municipal solid wastes, MSW, or any carbon-bearing materials as a waste stream, including biomass, coke, medical and sewage treatment waste, more particularly wet waste materials. Metals and glass are removed via conventional methods prior to feeding the kiln and are recovered for recycling value. MSW is not required to be dried prior to processing and may be left wet. Here we have a further visualization of the steam reformation process. As part of the feed system, municipal solid waste, MSW, is first shredded, then segregated and preheated. Commercial lime is added to the shredded feedstock to prevent the formation of chlorides and to eliminate the formation of halogens, furans, dioxins, and acid gases that may be formed in the kiln from contact with oxygen at elevated kiln temperatures. The addition of lime forms benign calcium salts are removed with the char. This material is fed into a hopper containing a screw conveyor and charged to the steam reforming kiln. At the kiln entrance, high-temperature steam is introduced continuously to purge the MSW of atmospheric air, nitrogen and oxygen, NOx, and to prevent the conversions to toxic and undesirable nitrogen oxides and/or other oxidized products. The rotary kiln reactor is where the steam reforming reactions occur. The first stage kiln is heated externally to a temperature range of 550 to 650 degrees Celsius to initiate the treatment, providing sufficient temperature, turbulent mixing, and residence time in the first reaction zone to achieve the target conversion levels, with any carryover metallic materials intact and residual carbon char formed. The first stage products are segregated into 2 streams, a second stage dusty gaseous stream and a third stage solid stream. Dust and particulate matter are captured and removed between the first and second stages. The second stage gaseous stream is passed to the second stage steam, reforming kiln that elevates the reforming temperature to 850 to 1100 degrees Celsius, or higher if necessary to complete the reaction. This second stage facilitates the complete conversion of the carbonaceous gases to a syngas consisting primarily of hydrogen, H2, and carbon monoxide, CO. The third stage further processes and removes solid materials from the raw syngas. Additional fourth stage facilitates the opportunity for higher conversion temperature and longer resident times as MSW composition dictates. These stages are designed to increase efficiency, maximize the output of syngas, and reduce to a negligible amount of inert materials. Inert materials such as ash can be used in conventional building materials and road paving. The secondary cleanup and polishing of raw syngas and its distribution within the process take place in the following manner. The process design optimizes heat recovery to optimize the efficiency by recovering heat to be reused in the heating and preheating stages. The various stages of gas cleaning uses existing conventional technology and equipment at very specific conditions and in a very specific sequence. It results in a very clean syngas with high hydrogen content. Following the main process steps, the diluted syngas is fed to a combined cycle gas turbine, generating electricity and steam for the plant requirements and providing additional electricity for sale to the local grid. Output is a planned 9.5 MW gross and combined cycle from the designed 50,000 ton per year reference facility. Does steam reforming really work? A pilot demonstration plant was developed and built in Ontario, Canada, and was operational for a full 5 years, with approvals from the Ministry of Environment and Climatic Change, MOECC approvals Air and Waste, in Ontario for an Energy from Waste program. In addition, confirmation of all steam reformation technology metrics and core technology design was validated. Steam reformation is a proven methodology and application with existing technologies, resulting in high-content hydrogen. Power production from waste fuel was successfully tested. The ALT Complete system uses state-of-the-art industry equipment and standards in a unique proprietary way to divert waste from landfills. Operational risk is minimized as no special materials, equipment, or catalyst are required. Steam reformation is proven and it works. Carbon emissions. The ALT process is carbon neutral. Avoidance of long-term landfill gas, LFG, methane, 9 times plus versus CO2, and release into the atmosphere can significantly reduce greenhouse gas exposure. Scalability, plant sizing. Our plant design and operating requirements are very cost-attractive in comparison to other technologies. Our plants are scalable in kiln multiples of 50 kT. Examples include this floor plan for a fully developed architectural design concept for one 50,000-ton plant, or our fully developed site drawing for two 50,000-ton per year plants, with trucking details including trucking routes in and out of the property. An Option 2 layout for a full site for two 50,000 tons per year plants, with revised site conditions, and a front and side elevations representation of our proposed plant for two 50,000 tons per year. And we are confident you will see the value and the enormous potential of its environmental, social, and economical benefits applications. We look forward to meeting with you to further our discussion